Today I'm going to show the determine the uh, mind the ultimate moment of resistance of single reinforcement section for a balanced section. Uh, that's when the concrete concrete in this one section is in compression, and this one is in tensile state. And this is the single reinforcement beam, where we have reinforcement in the tensile side. Okay. Mm. And this one is the diagram, is the cross section of beam, and this is the strain diagram, and this is the um, ultimate strain for concrete, and this one is the ultimate strain uh, for the steel. And then this is the design value of the tensile value of the concrete in compression, FCK upon gamma c, and this is the design L strain of reinforcement, FYD FYK upon gamma s. Today I'm going now we can take this value from the Eurocode 2. First I will show the value of strength in ultimate strength for the concrete class, uh, for the strength concrete of 50 by 60. We will take this value from here, this diagram. This grammar we have the value 50, and in 50 for 50 we have EC2 35 percentage. This is percentage, and if we divide by 100 we will get this value. And next one is alpha cc. For different between we take this value 0.85. It is for the for different bending strengths and cylinder crashing value. We take this value from, let's go, uh, everything is in Eurocode. Need to look it. I'll show this. Okay. It is not here, but I will show the partial factor of safety for concrete is 1.5. From where we get this is one in his is 1.5 for concrete, and for reinforcement it's 1.15. And then after 1.15 we have taken the Young modulus of steel is 200 kN per mm square, and Young modulus of steel is equal to strength upon stress upon strength. Okay, and we have formula here. Let's go to the formula for where we can get the value of design L strength of reinforcement. It is just in, yeah, diesel compressive strength tensile strength gamma 6 cc FCK by gamma c. This is our value, and it is given like this. The alpha cc is for your countries, it lies between 0.8 to 1, maybe from the international nx. So for this one we have taken 0.85 for different bending strengths and cylindrical crossing strength. This is all we have our diagrams now. And now go for the calculation. And it L strain means L strain for concrete is stress upon Young modulus of steel, and uh, for steel stress is equal to FYK design L value of concrete upon gamma s. So F, and then after Young modulus of S, we have suppose the Young modulus of steel is 200 kN per mm square, and at ultimate state of for Y, and L value of for steel is 500 Newton per mm square. Let's go the L value for steel. Then is 500. L value of steel is 500. Okay, and design character steel strength of steel is 500 upon partial factor of safety into Young modulus of steel, and we get the strength strain strength of tensile reinforcement. So this is our value. Now we can see that EC2 is equals to distance x upon from the figure is equals to EST upon D minus x, and by solving this equation we get the value of x is equals to 0.61860. D minus, we have arranged the equation D minus x upon x upon strain of tension upon concrete. We have arranged this one, and we get the value x is equal to 0.1860. To ensure the yielding of the tensile state at ultimate limit state EST, strength of tensile should be greater than still of strain young yield strain. So it should be greater than yield strain to fail in the tensile, and the x value should not be greater than 0.617 d, which we get from this calculation.